boundary between Earth observation and orbital defense is rapidly disappearing. There was once this distinct domain of space situational awareness and geospatial intelligence, and now they're interdependent forces, which are working together to safeguard space assets and global security. While SSA focuses on tracking objects in orbit, analyzing debris behavior, and predicting potential collisions, GEOINT provides the contextual framework, bringing in location-based intelligence, terrain analysis, mission relevance, and operational overlays. And so when we put them together, they create this paradigm for understanding and managing the increasing congested space environment. SSA delivers the where and what, where objects are, and what their paths could be, but GEOINT answers the why it matters question. And so when there's a potential conjunction, and that's identified between possibly a piece of debris and an operational satellite, SSA systems, for example, like CARA or ORDM, calculate a likelihood of an event. For example, could be a collision or a conjunction. But it's GEOINT that connects that orbital risk to ground assets, real-time mission windows, or geopolitical implications. And so that geospatial framing transforms space data from just a bunch of numbers into now practical insights. And those insights, operators and mission planners can act on in real time. And so in other words, SSA would give us awareness, but GEOINT can assist with the meaning behind that awareness. One way to look at this. So as of May 20th of this year, 2025, NOAA's Office of Space Commerce officially rolled out TraCSS, and that program increment 1.2, which allows satellite operators to instantly screen for potential collisions and submit large batches of orbital data in real time. And so by July 14th, 2025, SpaceX joined as the 10th beta user of TraCSS, validating the system at scale. Now, when we look at operational use, SSA-generated conjunction alerts can now be overlaid with GEOINT layers. And so think about it, things like ground infrastructure, launch corridors, mission zones, to assess a downstream impact. And so another example, when TraCSS CDM flags a Starlink satellite conjunction, for example, GEOINT platforms can map it against terrestrial assets to evaluate whether the risk affects critical infrastructure and inform whether an invasive maneuver is warranted. In May of this year of 2025, NGA, the National Geospatial Intelligence Agency, and the U.S. Space Force finalized a landmark memorandum of agreement to better synchronize their handling of commercial ISR and space-based data collection. And according to the 2025 congressional testimony and Vice Admiral Whitworth's remarks, NGA's integration with Space Force through the Joint Mission Management Center formalizes a seamless workflow. And so when orbital activity, such as an anomalous maneuver, is detected, NGA's informed collection orchestration framework can enable real-time GEOINT overlays. And so analysts can map these events against terrestrial and geopolitical layers, which provides commanders not just with collision warnings now, but actual mission contextual risk assessments. And so, for example, if TAC SRT flags unpredictable satellite behavior, NGA can evaluate whether it coincides with sensitive infrastructure or regional operations. And so that now reflects a new level of SSA and GEOINT fusion, where orbital awareness translates directly into terrestrial decision making. And so that integrated need becomes a central motivation in my research, which explored how we can better organize and prioritize the chaos of space debris. And with that being said, I use machine learning as a pre-processing technique, specifically DBSCAN, which is density-based spatial clustering of applications with noise. And if you haven't checked out my previous video on that, I'd say go ahead back and check out my video on DBSCAN. But anyways, I developed a methodology to categorize orbital debris based on shared orbital characteristics. And so I looked at features like eccentricity, inclination, mean anomaly, and different orbital element fields. The idea was simple. Instead of treating every single object as a sort of single object, why don't we look at similar patterns of behaviors? And so essentially the idea was to look at clusters, again based on similar orbital characteristics. And so when I did that, the clusters revealed different key differences. So first off, we have to find our baseline of behavior, which was cluster 0, and that's our baseline for comparison. And then cluster 2, for example, shows predictable low-risk behaviors, potentially because, again, these are all based on initial risk assessments, where things like cluster 1 represents noise, could be potential high-risk outliers, and they don't belong to any sort of stable pattern, and so they could potentially pose an elevated risk, so we should treat those differently. And so by organizing the debris into data-driven clusters, we can help both SSA and GEOINT teams reduce noise, streamline resources, and focus on what matters most and most critical to missions. And so SSA systems can feed these different clusters into their conjunction assessment workflows and processes, knowing which groups are most likely to produce possibly a false alarm versus a true threat. And again, all of this is based on an initial risk assessment. And so GEOINT systems can visualize these clusters across orbital maps, overlaying geopolitical priorities, or again, geopolitical priorities or mission critical assets to generate timely, mission relevant intelligence. And so in the past, what was once sort of based on orbital telemetry is now strategic decision support. And so the benefits of this go far beyond sort of what we see in the academic world. So looking back through some of my research, in 2023, for example, the International Space Station had to perform multiple debris avoidance removers. And this caused several instances of, again, sort of preventive maneuvers and things like this, which cost money, costs fuel, and in some cases it could compromise science, research, and crew safety, which of course the crew safety is the most important part of this and piece of this equation. And so with enhanced SSA and GEOINT collaboration now, we can inform this by doing that clustering analysis. Those decisions can be made faster with greater confidence and fewer false positives. And so instead of us reacting to sort of every single alert, operators now can filter threats by cluster behavior, risk category, proximity to mission priorities, and that can lead to smarter, safer orbital operations. And so this partnership is also driving advancements in policy and international coordination. So for example, agencies like NASA and ESA are pushing for open data sharing, standardization of debris catalogs, increased use of machine learning to automate risk detection. And GEOINT tools, which were traditionally used to monitor terrain or battlefields, now we're using them just as likely to monitor LEO, so low Earth orbit, for example, as it's starting to become one of the most congested domains in human history. And so as we have these commercial entities putting up mega constellations and they grow and grow, and as multiple nations kind of join into this and they're continuing to test the boundaries in orbit, the integration of SSA and GEOINT is becoming extremely essential. And so looking ahead, the future of space sustainability is going to hinge on those two disciplines really staying aligned and working together, which is why this partnership was so critical that I mentioned a few moments ago. And so whether we're looking at mapping orbital behavior in real time, anticipating conjunctions, days in advance, responding to emergencies from both space and Earth perspectives, this SSA and GEOINT alliance forms the backbone of modern space defense. And so when we add in, different machine learning techniques or pre-processing techniques, as I said prior, with clustering, for example, like the one I used in my study, we now have the tools to bring structure to orbital chaos and turn that structure into actionable insights. And we have to remember, in the end, space isn't just about satellites and sensors, it's about people. It's about missions, and it's about protecting the invisible infrastructure that we're all relying on every single day. So from GPS communications to national defense. And so that's really where we have this synergy of SSA and GEOINT working together, showing its true power.